Alright, so in this video now, we are going to look at the catabolism of purine. Catabolism of what? Purine. Now, for the catabolism of purine, this is the part where you have to draw. This is what you have to draw. There's nothing you are writing as word. Everything is pathway. So I will walk you through the pathway. It's very, very easy. Now, if you notice, at this level, we have nucleotide. Everything here in this line is a nucleotide. You know, nucleotide are those AMP, GMP, ADP, ATP. All those ones that are having phosphate are your nucleotide. So yes, adenosine monophosphate, inosine monophosphate, guanosine monophosphate. Now, if we move from this nucleotide level, if we move down, what we are going to get will be what? Nucleoside. So this level is the level of nucleotide. I get my point. When we now move to this place, what do we get? Nucleoside. Meaning that we've lost what? We've lost what? Phosphate group. I get my point. So let's do it again. This level is what? The nucleotide level. AMP, IMP, GMP. They will be broken down, meaning we are going to lose the phosphate. When we lose the phosphate, what we get will be a what? A nucleoside. A nucleoside without phosphate. So from AMP, how do you lose the phosphate? You add water. So if you notice in all the reactions, I'm adding what? I'm adding water to it. Can you see it? All right, I'm adding water to it. Then when we add water, we lose what? Phosphate group. You can see the phosphate as Pi, inorganic phosphate. We lose the phosphate group. Is it clear now? All right, it's clear, okay? Now, once we lose phosphate from this one, the nucleoside we have is what? Adenosine. From here, we get within inosine. From here, we get within guanosine. Are you getting my point? From here, we get within guanosine, okay? Now, what is the enzyme we use for it? The enzyme we use for it is called within nucleotidase. Nucleotidase. Please take note. Tidase. Nucleotidase. Nucleotidase. That is the name of the enzyme we use. Now I'll move from nucleotide to nucleoside. If I want to go down again, I'm going to remove the sugar. Okay? You know, nucleotide basically consists of what? Consists of a sugar, a base, and what? Phosphate. So from tied to this side, we lose the what? The phosphate. While the next thing we will now lose if we are to go down again is the what? Is the sugar. So that's why, if you notice, inosine is converted to what? Hypoxanthine. Hypoxanthine is a base. In like manner, guanosine is converted to what? Guanine. Guanine is a what? It's a base. Are you seeing it? Are you seeing it? So if we are moving down again, what we get is what? It are basically bases. Okay, good. Now this adenosine, the enzyme we have basically convert adenosine to what? To inosine. So we are not going to convert adenosine to adenine. What we do basically is that we use an enzyme that is called adenosine deaminase. Then we will now shunt adenosine to form inosine. Then from inosine, we are going to form hypoxanthine. So what do I say? I said at this level, everything here is nucleoside. If you are going down, you are going to get the bases, all right? Meaning you are going to lose the sugar. Okay? Now, I said for adenosine will be converted to what? Inosine. Then you know what will happen to inosine, right? Inosine will be converted to hypoxanthine. This one will also be converted to guanine. These are the bases. Okay, good. Now take note of the enzymes. The enzyme we use for inosine to hypoxanthine will be a nucleoside phosphorylase. So we have purine nucleoside phosphorylase. Purine nucleoside phosphorylase. For short, we call it PNP. PNP. That is the enzyme that we use to convert the nucleoside to the base. So what does this enzyme do? This enzyme add phosphate so that it can remove the sugar. So the enzyme what? It add phosphate. It basically add phosphate and remove the sugar at what? As ribose 1 phosphate. Again, add phosphate, remove the sugar as what? As ribose 1 phosphate. Okay? Alright, so that is for that. Now once we've gotten our hypoxanthine, we come back to this. Remember this one, adenosine was converted to what? To what? To inosine, right? The enzyme here is very, very important. This enzyme here is very, 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 very important. The enzyme there is called waiting adenosine deaminase. ADA for short. Adenosine deaminase. Adenosine deaminase. adenosine. They are very, very important. The enzyme that convert adenosine to what? To inosine. All right. Now we've gotten our hypoxanthine, we've gotten our guanine. Hypoxanthine now will be converted to what? To xanthine. So basically, what we do here is we add the same reaction. We add H2O plus oxygen, and we form H2O2. Okay, so we are going to oxidize this hypoxanthine to what? To xanthine. Then this your guanine here will also be converted to what? To xanthine by removing ammonia group from it. You add water to remove ammonia group from it. So this one will be called guanine deaminase. That will be the enzyme here, guanine deaminase. Guanine deaminase. It's a deaminase enzyme, removal of amine group. Okay. Now once you've gotten your xanthine, xanthine now will be converted to what? To uric acid. So that's why we have uric acid as the end product. Can you see that the pathway is very, very simple? This level is the level of nucleotide. This level is the level of nucleoside. Then this level is the level of what? Thought to be this one is just that we first form hypoxanthine. Hypoxanthine is a base. This one is also a base. So that is it. Even xanthine is also a base too. It's also a base. So this level is the level of what? Base. However, before you form xanthine, you will form what? Hypoxanthine. Is that not so? Okay, very, 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 very simple. Very, very, very simple. Take note that adenosine was not converted to adenine, rather it was branched to form with inosine. And from inosine, we now form hypoxanthine, xanthine, like that. Okay, the pathway is very, very, very simple. Where's the first enzyme here? This first enzyme is called waiting. It's called waiting. Nucleotidase. Nucleotidase. It uses water to remove the phosphate. Nucleotidase. Use water to remove the phosphate. Nucleotidase. Use water to remove the phosphate. This one is called PNP. PNP enzyme. Purine nucleoside phosphorylase. It uses phosphate to remove sugar so that you can have the bases. Okay. Use phosphate to remove sugar so you can have the bases. Then take note of this enzyme again. Adenosine deaminase enzyme. Lack of this enzyme will cause a disease called SCID. I get my point. We call the disease severe combined immunodeficiency. Okay. Now at the end of the day, we are going to have uric acid. This enzyme here is called xanthine oxidase. Xanthine oxidase. Same thing that is also doing it here. Xanthine oxidase. Okay, xanthine oxidase. All right, so that is it. This is everything about the breakdown of purine nucleotide. Just to recap it again, we have nucleotide, we have nucleoside, we have bases. From nucleotide to nucleoside, what do? You remove the phosphate by adding water using nucleotidase. Then from nucleoside to bases, you add phosphate to remove the what? The sugar. Then notice that this one will come to here, adenosine deaminase. Notice that guanine will also form xanthine. Then finally we form uric acid. So this is a brief recap. Okay. In the next video, we are going to talk about adenosine deaminase deficiency.